In this video, we are going to look at exponential properties. There's going to be two parts to this video. The first video is going to be just the properties themselves with a couple of just distinct examples as to why the properties work. The second one is going to be putting them together, going through some different examples so you can see how does this fit together with all of the properties as a whole. So to begin with, when I talk about exponential properties, the first thing we need to make sure that we have is a common base knowledge. The 3 has a specific name, which is the base, and hopefully that kind of makes sense. It's the bottom part to the top, which is your exponent. Excuse me, and the whole thing is called a power, the whole 3 to the 5th. The entire piece is that power factor. So we have individual names, and then we have the whole thing. The base plus the exponent is called the power. So we're going to look at, there are a bunch of different properties in here. Please keep in mind, I don't expect you to have these memorized by name, but the name should hopefully kind of help you make sense of what the actual property itself is. So the first one says the product of 2 powers with equal bases. So for instance, x to the a times x to the b. I have 2 different powers, and they each have the same base. Whenever this happens, all I do is I rewrite the base, and that's x to the a plus b. I physically add the exponents. And this is a common misconception of what do I do with them? Do I add the exponents or do I multiply the exponents? You do physically add the exponents. Now, the reason why this happens is if I were to have an example such as x to the 3rd times x squared. Well, what does x to the 3rd mean? X times x times x. Well, what does x squared mean? X times x. Well, it's all multiplication, so x times x times x times x times x is just x to the 5th. There are 5 x's that are in there. That's why we physically add exponents. Now, please be careful that with this, you also have to be able to go backwards. If I give you x to the a plus b, you have to know that's the same thing as x to the a times x to the b. We tend to get really good going from the first one to the second one, but then being able to take that property and go in reverse, that's sometimes the struggle piece with it. So keep in mind, these properties go both ways. It's not just, okay, this equals this. They also go back around. Now we also have a quotient of 2 powers with equal bases. Very similar. Difference is it's quotient, it's dividing. So this is going to be x to the a over x to the b. Exact same bases. When we're doing division, that's the same thing as x to the a minus b. Reason being, if I have x to the 5th over x squared, x to the 5th is just simply x times x times x times x times x over x squared, which is x times x. So when you think about simplifying, those x's go away because it's all multiplication. These x's go away. So my result is x to the 3rd. You subtract 5 minus 2. And that gives you the second property. The next 3 is power of a power, power of a product, and power of a quotient. For power of a power, this is like x to the a, and then that whole thing is taken to the b power. Well, this is just x to the a times b. This is when I physically multiply my exponents. This is when I physically multiply those exponents, when I take a power to another power. So an example of this would be x squared to the 3rd. So x squared is then taken to the 3rd. So it's x squared times x squared times x squared, because there's 3 of them. Well then, if you go back to what we were talking about before, x squared is just x times x squared is x times x squared is x times x. So the result here is x to the 6th. That's why when we take power to a power, or power of a power, we physically multiply them. The next one is power of a product. So I have something that's multiplied, x times y, and it's going to the a power. If I have something taken a multiplication taken to an exponent, that a sends over to both of the bases. It's not distributing. Distributing is over an addition, but it's kind of along the same concept. Reason being, for number 4, that's the same thing as saying 4x squared. 4x squared. 4x squared means there's 2 of those. 4x times 4x. Well, it's all multiplication. There's multiplication signs between there. So group your like pieces together. 4 times 4, that's 4 squared. X times x is x squared. Well, 4 squared, of course, you know is 16. But that exponent gets both bases. So it's each of the individual bases to the second, because it's all multiplication to that exponent. Please note that there are parentheses around it. There are parentheses around it. This is not equivalent to that. 4x squared means just my x's squared. There's no parentheses, so it does not include the 4. So be cautious of that. My 5th property is power of a quotient. For power of a quotient, it's x over y to the a. Same process as power of a product. Numerator and denominator both get the exponent. Numerator and denominator both get the exponent. Reason being, for property number 5, 4 over x squared. Well, that's the same thing as 4 over x times 4 over x, which is the same thing as 4 squared, which again you know is 16, over x squared. So that squared goes to both of them. So that's why those properties work as well. The previous properties were properties you've used before, you've seen before. These next properties are ones that you haven't necessarily been exposed to in the past. So hopefully the discovery activity that you worked on helped see some of that. The first one is exponentiation for 0 exponents, which means if my exponent is 0, what do I get? X to the 0 is 1. Anything to the 0 is 1. So going back to what you did in the discovery activity, 2 to the first you know is 2. 2 squared you know is 4. 2 to the third is 8. 2 to the fourth is 16. You're usually very comfortable going forward. You can keep going. You'll eventually get used to most of the 2's with the bases of 2 to different exponents. But if you look, going from 16 backwards to 18, what'd you do? You divided by 2. Because going forward, you multiplied by 2. Therefore, going backwards, you divided by 2. Going backwards again, you divided by 2 again, divided by 2 again, divided by 2 again, gives you 1. 2 to the 0 is 1. So this is our first property that we're going to look at. Anything to the 0 is 1. Next one talks about negative exponents. Because in the setup, my next number has a negative exponent. We keep going. We divide by 2 again. Well, 1 divided by 2 is a half. I divide by 2 again. Now that's a fourth. Well, 1 over 2, 1 over 4, this is really 1 over 2 squared. Those are equivalent statements. Next, 2 to the negative third would be 1 over 2 to the third, which is 1/8, because when I divide 1/4 by 2, I get 1/8. And I can keep going backwards the same way. So if I have exponentiation for negative exponents, if x goes to the negative n power, that is the same thing as saying 1 over x to the n. I have a silly way of remembering this. By no means is it mathematically relevant. But what happens if you ever have a negative exponent, you press that negative sign. It takes its base and the exponent and pushes both of those to the denominator. A negative exponent takes its base that it's attached to, and its exponent, and pushes it all to the denominator. And there's no negative sign anymore. You got rid of it when you press that button. It's the elevator button is what I call it. So, anytime you have a negative exponent, just like back here, 2 to the negative third, I take its base and its exponent and I push it to the bottom. Now the same thing works if it's in the bottom. I press that button and I'm in the basement. I can't go any further. Therefore, I end up on the first floor. So if it was in the denominator, I push that button, it goes up to the numerator. And then the last two are dealing with radicals. Exponentiation for reciprocal exponents and exponentiation for fractional exponents. The first one is a reciprocal exponent, x to the 1 over n. It's a reciprocal exponent. Usually it says x to the n. However, it's 1 over n. If that's the case, this is just a root. This is the nth root of x. So if x goes to the 1 over a number, that denominator is the actual root that it is. If it was to the 1/2, it's the square root. We don't usually put a 2 in there if it's a square root. If it was 1 over 3, it's the cube root. Then you have to write the little 3 inside of there. Okay, depending on whatever that denominator of the exponent is, that is the root that we're dealing with. The other one is exponentiation for fractional exponents. It goes along the same path, x to the a over b. The denominator is its root. So the denominator is the part that goes inside this part right here. That's always the denominator. Then, the numerator piece, the a, is the actual power that it's going to. So x is going to the a power. It does not matter whether you do the root first or the exponent piece first. No matter which way you go, you will get the same answer. The thing is if you can, it's usually easier if you break down your root first. If I try to take the square root of something before I start taking it to the third power, that's going to be a helpful piece of information just to keep your numbers smaller. So what we're going to do is I'm going to go through, in the next video, I'm going to go through some examples of these that put them all together. And then in your worksheet, you're going to have a whole bunch more of these that kind of fit everything together.